Greetings everyone, my name is Jasper Requilme, BIT Comtech 3 Night student at CTU Mall campus. I'm making a reaction video for lesson 1 and lesson 2 of Mr. Manuel Escabas. Let's go. Microcontroller versus microprocessor. A microprocessor simply consists of the processor, the ALU or arithmetic logic unit, the instruction decoder, and a few registers which are used to store data for mathematical and logical operations. A microcontroller includes a processor, the ALU, instruction decoder, registers, code storage space, flash memory or ROM, RAM, general purpose input-output pins, timers, interrupt controller, serial communication module, etc. That is, the microcontroller is a microprocessor with some basic modules. The difference of them is microprocessor consists of only a central processing unit, whereas microcontroller contains a CPU, memory, input-output all integrated into one chip. Microprocessors uses an external bus to interface to RAM, ROM, and other peripherals. On the other hand, microcontroller uses an internal controlling bus. What does technology has to do with it? Technology is already demonstrating how the influence or how tremendous potential on the way we think, learn, and interact. It helps us shape the new ways in which people are communicating, collaborating, operating, and forming social constructs. Examples of technologies: digital gaming, social networking, and simulation. Digital gaming. A digital game is an interactive program for one or more players meant to provide entertainment at the least and quite possibly more. Number 1 is rules. Yes, there is always a rules in the game in order to know the game or how to play the game. Next is goals and objectives, outcomes and feedbacks, conflict or competition, challenge, opposition, and interaction. In digital gaming is not all about fun. It also improves coordination, improves problem solving, enhances memory, improves attention and concentration, improves the brain speed, enhances multitasking skills. Social networking. You can post a profile, photos, videos, chat, blog through social media like Facebook, Instagram, and connect with peers through like your loved ones. Simulations. Simulations are analogies of real-world situations according to Prensky, 2001, as they recreate a modeled or modified version of a real-world situation. Examples of simulations are VR or virtual reality. First generation. From 1971 to 1972, the era of the first generation came, which brought microprocessors like Intel 4004, Rockwell International PPEs for Intel 8008, etc. Second generation. The second generation marked the development of 8-bit microprocessors from 1973 to 1978. Processors like Intel 8085, Motorola 6800 and 6801, etc. came into existence. Third generation. The third generation brought forward the 16-bit processors like Intel 8086, 80186, 80286, Motorola 68000, 68010, etc. from 1979 to 1980. This generation used the HMOS technology. Fourth generation. The fourth generation came into existence from 1981 to 1995. The 32-bit processors using HMOS fabrication came into existence. Intel 80386 and Motorola 68020 are some of the popular processors of this generation. Fifth generation. From 1995 till now, we are in the fifth generation. 64-bit processors like Pentium, Celeron, Dual, Quad, and octa-core processors came into existence. Typical features of 32-bit and 64-bit microprocessors. A 32-bit allows the arithmetic and logic unit or ALU or digital circuit to perform 32-bit integer arithmetic and logical operations. For 64 bits, it allows a 64-bit version of Windows to handle large amount of RAM better than a 32-bit system. The difference of 32-bit and 64-bit is 32-bit operating systems can allocate only 4 gig of memory, whereas 64-bit ones can allocate a lot more. It is a good practice to install 64-bit apps on a 64-bit OS because they will be able to use all of your computer's memory if you have more than 4 gig. Microprocessors and applications. A microprocessor makes daily life easier because of its low cost, low power, small weight, and vast application in every field. There are several applications of microprocessors. Some of the important applications are household devices, industrial applications of microprocessors, transportation industry, computers and electronics, in medical, embedded systems at home, office automation and publication, and communication.